Hey, what's up, my crazies? Thank you for coming to this channel to look at the review video. I think that's great. You're definitely on your way to doing the right thing in this class, and keep it up. I'm glad to see that you're here. I'm going over just the odd problems starting at number 5 because you did the first few in class and they were very easy. So I'll start with 5 and take it from there. If you have any questions, shoot an email, come to Extra Help, and good luck on your test. Okay, so this first question, graphing a piecewise function. Okay, so we're basically drawing three functions, but only across certain domain values. So for example, this guy right here, x squared, you would agree sort of looks like this. But we're not interested in all of that. We only want it from -2 to 2. So we would want to slice it off from here to here. So that would mean getting rid of this, perhaps, and this, you know? So how do we do that? I would suggest using your calculator, plugging in these three functions, and let's see if we can grab some values and then graph accordingly. Okay, so I went into my calculator and I put in the following functions that we wanted. 2x plus 8 in y1, x squared in y2, and -5 in y3. I thought that that order would be good because as we move from left to right on the x-axis, those are the functions that we want. So 2x plus 8 will be the function on the very left because that's everything less than -2. The function x squared, like I showed you before, will just occur between -2 and +2, so I made that the second function. And the last function is -5 when it's greater than or equal to +2. So sort of the way that the graph will look from left to right, I've also placed that in the order from y1 to y2 to y3. So if you graph this, there they are. I've got the line on the bottom. This line right here is the -5. Here's the parabola that we drew just a few moments ago. And then here is that line, y equals 2x plus 8. But of course, we're going to want to chop them off at the desired locations depending on what the piecewise function said. So this can help you to at least identify what your graph should look like and where. If you go to your table of values, it might also be beneficial to help plot some of those points. So for example, looking at the table, here are all the x values, the domain values. And for our first function, which was the line, here are the points we should plot. For the second function, which was the parabola, here are the values we can plot. And if you arrow over to the right, you can find our third one, which is kind of funny. They're all -5, but that's because it's a line, y equals -5, so you should expect that. So no matter where you go on your domain, we're just going to plot -5s. And that's it. So I would use all this information to plot what I wanted. Okay, so let's graph those points. Let's take the line. We had some points over here. I believe it was -2, 4. And right away, I see something incorrect. Look at the domain for the line. It's less than -2. So in order to do that, less than -2, I've got to put a hole around that point, at least for that line. Okay, so then the other points were -3, +2. That would be right here. And that's really all you need to connect a line. You just need 2 points. So I'm going to sketch this. It won't be perfect. But that's what that guy looks like. So now for the parabola, that was the x squared. We only wanted it to be from greater than or equal to -2, and then less than +2. So if we looked back at that table of values and we plotted the points, where you saw -2, you would see 4. So for that one, we would fill it in and then plot some of the other points on the parabola, at least so we can make a nice sketch. Now when we get to this point here at positive 2, you have to put a hole here. Okay, so let's just sketch it now. There you go. Now what was the third part of our piecewise function? It was -5 only where x was greater than or equal to 2. So I'm going to go down to 2 and I'm going to plot some of those points. So 2, -5, I'll fill it in because for this function it was greater than or equal to this value. I'll plot one more point at -5 and connect a line. That's what the function should look like. And maybe I'll make this one green just to show you the difference in the three functions. There you go. Okay. Now evaluate the above function. So this just means depending on where you are is where you're going to go. So for example, if I'm at -3, I'm going to say my value would be 2. When I'm at -2, I look up and I'm part of the parabola right now. And that value is 4. Last but not least, +2. If I go along the x-axis to +2, okay, I am not the parabola because notice the hole. I live down here on that line we graphed, and that was -5. Okay, so that is graphing a piecewise function and then evaluating. Okay, so I'm going to do 8 also because if you look at this, simplifying radicals, usually we do the good house and the bad house. But this question is a little bit straightforward because 64 is a perfect square. There's really nothing to simplify. So, you know, this already is just 8. And when you bring down the -4 and multiply that by 8, you have -32. So let's focus on number 8. 180, that's not a perfect square. So what we want to do is one of two ways. By hand, let's do a good house, bad house. Or we can use the calculator, which is really fast and nice. But I'll show you this way first. Okay, so 180. What are factors of 180 that have perfect squares in them? Well, I know that 36 times 5 is 180, and that 36 is a perfect square, and 5 is not. So the last step is to simplify now. Let's clean up these houses. So 36 becomes 6. Let's bring down that 5 and bring down the radical 5. Simplify your answer. We have 30 radical 5. So let's go to the calculator because sometimes 180 isn't that easy. Maybe it's like 720, 1090. Who knows? Any random number you can think of that wouldn't be so easy to get perfect squares out of. I could show you right now the calculator is a great way to do that. So I'm going to minimize this and I'm going to go to the calculator and watch what happens. So whenever you're trying to simplify perfect squares or even cubes, whatever you need, fourths, doesn't matter. This way will always work out very nicely. You take your number, which was 180, type that into your y equals, and you will divide it by x squared. So your screen should look like that. Now, if you needed cube roots, divide by x cubed. If you needed fourths, divide by x fourths, and so on. Your final answer is going to be in the table of values. So watch this. Second graph for your table. You need to go down until the y values, these guys that are highlighted in black, are less than 1. In other words, let's get down to some small decimals. So I'm still going down, and I think I'm pretty close. Yeah, here we go. Okay, so 0.9. If you don't do this, you'll get a non-simplified answer. You want to go as far down as you can to below 1. And now work your way back up and stop at the first set of whole numbers that you see on the left and on the right. There it is. So I see 6 and 5. That's your answer. Not even a good house, bad house. That's the final answer. The number on the left is the outside number. The number on the right is the radical. Okay, we're back, and sure enough, 6 radical 5. So either the long way or the calculator method. I prefer the calculator method, especially if the numbers are very large and hard to figure out. Okay, so number 9. 9 and 11. When it comes to simplifying i's, we had again two methods to use, either by hand, where we needed to know this, that we had our I chart, I to the 0, which is -1, I to the first power, which is I squared, -1. Whoops, let me change this to +1, sorry. And then I cubed would be -I. That's our I chart. Now, how it's used would be to take your exponent of the I, 101, divide it by 4. So 101 divided by 4 equals 25.25. This is what you're concerned about right here, that decimal remainder. And you want to ask yourself, how many quarters would that be? Like if you had quarters in your pocket, and you had 25 cents, how many quarters do you have? You have 1. So that answer 1 is now your equivalent I. So I to the 101 is the same as I to the first. You have to go to your I chart now and say, hey, what are you if you're I to the first? Well, in this case, it's the simplest. You're just I. So that's your final answer, I. If you look at 71, again, 71 divided by 4, and that would give you 17.75. How many quarters is that? That's 3. So I to the 71st is equivalent to I to the 3rd. Now you have to go to your chart and say, hey, what am I if I'm I to the 3rd? I am -I. So that's the final answer. So let me show you in the calculator something called I part. That will also simplify your i's without having to use division or the I chart. Let's go take a look. Okay, so I part, very useful tool in the calculator. There's many ways to get there. And let me just take this moment to show you that if you ever forget where your functions are, but you know their name or you know what they sound like, you can always go to the alphabetical listing of every function the calculator has. And to do that, you hit second and you go to catalog, which is 0. Whoops. Second 0. There we go. This is an alphabetical listing of everything. So if I look at my green buttons and I go for I, it brings me down to the I's. Because it's alphabetical, I'll just scroll through and look if I recognize anything. And I know I'm looking for I part. So let me see where that is. There it is. Okay, so anyway, here's how you use this function. I part. You put in what you had. So what was the first question? I to the 101. So I, which is this little period down here, caret symbol, 101, close that parentheses, and what do we have? Bam, I. That was the answer we had. Let's try the other one. I believe it was, let me just bring up the last command. I think it was 71. Yep, 71. So let's see what that is. I to the 71. Negative I. Okay, so much faster, if you can remember it. And again, if you think you know what functions are, but you're not exactly sure of the correct name, try the alphabetical listing. It might be helpful. It might ring a bell. Once you see the function, you might realize that that's the one you were looking for. Factor completely. Not solving. I've seen a lot of students spend a long time solving when they didn't have to. It's not solving, just factoring. So step one in all factoring is GCF. No matter what, always check for a GCF. It'll make your life so much easier. So I'm looking at 32 minus 4x, and I'm thinking a 4 would be common to both of these. So if I extract a 4, this is what I'd be left with. Okay. The next step is check for dots. Difference of two squares. This is definitely a difference, but these are not squares. Now, in this class, we do another thing next. We check for, I guess what you can call SOAP. It's the difference or subtraction of cubes. And if we have that, we'll use the SOAP method. So 8, is 8 a perfect cube? It is. And x cubed is obviously a perfect cube. So we're going to do this next. So we did GCF, and that led us to some cubes. So how do you factor cubes? SOAP stands for same, opposite, always positive. And we're going to use this formula. And the formula looks like this. Same, I have a subtraction, so it'll be A minus B multiplied by always the first one squared, always the second and the first put together like a sandwich, and then always the last one squared. But here's where the SOAP comes in. How do you know what signs go here? Because this never changes, just the signs do. That's where the SOAP is. Same, subtraction. Opposite. Okay, so that means this sign will be positive because it was negative. And then always positive means no matter what, this guy's an always a plus. So we need to know what our A and B is. So the A is the cube root of 8, which is 2. B is going to be the cube root of x cubed, which is x. So simply replacing those values in for the A's and B's, you've now factored the difference of cubes. So A was 2, B was x, A was 2, AB would be 2x, and B squared would be x squared. Almost done. It's just you usually have to do something here, right, to make it look nicer. So 2 minus x times 4 plus 2x plus x squared. And that is it. You're done. You stop right here. This is not solving. It's just factoring. Okay, number 15. Just like 13, GCF first, if possible. And yeah, we can GCF out of 3. And this is what we'd get. Second and third steps. Am I dots? Am I the difference or sum of cubes? Definitely not, because this is a trinomial. So now let's do this. The AC method, which is first times last, and let's split the middle term. Okay, so starting with the first times the last. 3b squared times negative 20 is negative 60b squared. Let's look for factors of 60. So I have 60b and 1b. 2b and 30, 3b and 20, 4b and 15, 5b and 12. These two right here can get me to 7, which is what I'm looking for here. I want to split the middle term into these two factors, or using these two factors, sorry. So these two have to multiply to be negative 60, which means one of these will be negative. And if it has to add up to positive 7, I'm going to say positive 12 minus 5. So now you rewrite this as follows. 3b plus 12b minus 5b minus 20. Now here's another method of factoring. Whenever you have 4 terms, we like to do the grouping method. We GCF the left, so we would take out a 3b, and we'd be left with b plus 4. Using this method, you know that the b plus 4 has to go over here in order for it to work. And what would be the factor that we can take out of these two terms that would leave us with b plus 4? That would be negative 5. So we combine the common factors on the outside, 3b minus 5, like that, so that we only have to write this factor once. And of course, like I usually do, don't forget to bring down the 3. This is the factored form. Again, not solving, just factoring. There it is. Number 17, perform the indicated operation. And the operation is this. Find h of g of n. Also written like this. Just so you know, these are the same. Sometimes a little o, sometimes nested parentheses. So the most important part here is the g goes first. And you pass the answer back to h. So first we'll do g of n, and it is what it is. It's 2n minus 4. Whenever you don't have a number, if you just have the actual letter, that's the answer you get. So we're going to take this and pass it over to h. So we're going to do h of 2n minus 4. Now, the function h says, listen, whatever you give me, put it right here. So that's what I'll do. And when you're done, add 4. So that's what I'll do. Now we're done. That was it. First came g, then goes h. But, you know, good mathematicians, we should combine like terms, simplify, make everything beautiful. So these actually end up canceling. And your final answer would just be 2n. Number 19, simplifying the expression. So we're being asked to divide two fractions, and hopefully you remember that we really don't ever divide fractions. We turn them into multiplication using their reciprocal. So the term we taught you was something called keep, change, flip, just so you can remember. And what that means is keep the first fraction, change the operation to multiplication, and then flip this thing over, just like I'm doing. Now, when you're multiplying fractions, you can cancel up and down. You could cancel crisscross. You just can't kill your neighbors. So this is a big no-no. Now, how do we cancel? We factor. This is a GCF. I'll take out a 3. And on the bottom, it's the AM method. What adds up to 4 and multiplies to negative 32? That would be these two factors, these two binomials, times nothing on the bottom. And the top is a GCF. Take out a 9 and This is what's left over. Okay, so let's go to town, canceling these things out if we can. Okay, x minus 4, there's a matching pair. Here's matching 8s on the crisscross. I can either take the 3 and the 9 and do a little reducing, or go to these easy ones there and just take the 9s out. And that was nice. There's nothing really left. So whatever's on the top, you just combine across the top. That's 3. And a bunch of 1s, right? These are just all 1s. And on the bottom, you combine, and those are just 1s. So final answer, 3. Beautiful. Okay, 21, same as 19, except we don't have to flip. This is just multiplication. So let's try again. GCF the top looks like, so probably a 20. X minus 1. On the bottom, definitely an X for the X's, and then a 2 for the 2 and the 8. So 2X is the GCF, leaving me with X plus 4. Cool. Oh, that's nice, because look, on the top you have X plus 4. So those are going to cancel. Let's see. I have X's, so definitely an X. One of them is squared, one of them is cubed. So here's the rule. Whenever you're trying to find a GCF of a variable, a letter, no matter what they are, I mean, they could be 5, 7, 9, it doesn't matter. Always take the smallest exponent, and that will be the greatest common factor. So if I'm looking at a 3 and a 2, I know the 2 is it. If it was 7, 9, and 10, I know 7 is it. It works just like that. And let's take a 15 because they both have 15s. Nice. Cool. Okay, let's go looking for pairs. X minus 1 on the diagonals, X plus 4 on the diagonals. This is working out nicely. This is where it doesn't work out so nicely. Okay, wow. Can't get rid of any more X's, so let's work with the numbers. We can't kill the neighbors, we're not going right and left. We can go up and down here. We'll take that 2 out, divide it by 2, and it makes that a 1. Divide this by 2, and it makes that a 10. Now, just because we already cut this one to a 10 doesn't mean you can't use it again with the 15. You certainly can. So let's divide this guy by 5, this guy by 5. And that's about it. Okay, so remember, whatever's left, you just combine the tops and the bottoms. So the top, it looks like 2 times 1 times 1, which is 2. And on the bottom, 1 times 1 times 3x squared. Whoops! Times another x. I forgot that one, sorry. So it's really 2 over 3x cubed. Okay, so solving inequalities and graphing the answer and writing it in integral notation. Okay, so first thing to recognize is these bars right here, they mean absolute value. And what we want to do is isolate that thing, get it all alone, and then solve it twice. So here for your notes, isolate it, and then solve twice. The most common mistake would be not isolating it first. And the second common mistake, so I just want to write this right here. I swear I've seen this so many times. This is not equal to 4. And if you were thinking that, I'm glad you're here, because that's not equal to 4. The 1 is an addition, it's adding, and the 3 is a multiplier against the absolute value. And here's something else not to do. While we're here talking about the don'ts, let's not distribute that 3, because it's not parentheses. So we're not going to do this. Please don't do that. That doesn't work either. So how do we solve this? Okay, first step, isolate. So I'll just rewrite it since I made all those notes kind of messy up there. Okay, isolate it. So that means, let's say, get rid of the 1 first, both sides, leaves us with 3 times the absolute value of 2n minus 4, and that is now going to be less than 12. Now, divide by 3, because that's a multiplier. That goes away. We're left with absolute value of 2n minus 4 less than 4. We're done with the first step. This is isolated, so that becomes the new equation. So we're going to solve this twice. First time, just like it looks, drop the bars and solve. Second time, drop the bars, switch the arrow, switch every sign on the right, no matter how many things you have. Switch all the signs. And now solve that equation. So let's see what we get. I'll add 4 on this one. 2n less than 8. Divide by 2. N is less than 4. Okay, that's the first answer. Over here, same story. We're adding 4 to both sides, except something interesting happens. You end up with 0. Dividing by 2, n greater than 0. That's the second part of our answer. So, on the number line, since it's only less thans and greater thans, I'm going to put holes on these values. I'm not filling them in because they don't have lines underneath. Now, should I shade inside or outside? Let's take a look. If I am less than 4 and my variable's on the left, that means my shading should go in the direction of the arrow. That's something to keep in mind for other types of inequality questions. If you keep variable on the left, then you can shade just like the arrow. It's just nice to have, if you're one of those students who has trouble thinking what do these arrows mean and who's greater than who's less than. If you keep your variable on the left-hand side, it's already showing you the way. So less than 4 goes that way. Now the other one was greater than 0. Look, it's pointing to the right, so that goes this way. Okay, so there's our answers on the inside. So interval notation. Soft bracket, smallest number on the left, comma, soft bracket, greatest number on the right. And the reason we use the soft brackets is because we had a less than or a greater than. We would use hard brackets whenever you had like a greater than equal to or less than equal to, because the one thing to remember about hard brackets is that they have this really cool built-in equal sign, which should help you to remember that they mean equals. Solving an equation, not just any equation, but an absolute value equation. So, if you remember from question number 23, the first step was to isolate the absolute value, and then the second step was to solve it twice. So let's do the first step, isolating this thing. I'm going to rewrite it a little neatly for the right-hand side so that it has a fraction type of look to it, like this, watch. I'll put this 1 over 1, so now it's just kind of lined up neatly. How do you get rid of a 2 in a denominator? Multiply both sides by 2. The reason I'm doing that is because that'll happen, which is beautiful. So now you're left with 3n plus 2 in absolute value notation, and that's going to be equal to 2. Okay, it's isolated. Now we solve twice. First time, drop the bars and solve just like it looks. Second time, drop the bars, but then switch every sign on the right. And that's it. So this is easy. Let's solve. 3n is 0. Divide by 3. N is equal to 0. Okay, but with absolute value, there's always like another possibility, so let's check the right-hand side. Taking away 2 here, not so easy. We get 3n equal to negative 4. Dividing by 3, which gets n by itself, you end up with this fraction, negative 4 thirds. But that's okay. Fractions are all right, no big deal. So the answer to this equation is n equals 0 and n equals negative 4 thirds. Oh, this is your favorite, everybody. Who doesn't love completing a square? Yeehaw! Okay, so for your notes, if you'd like, I'll just map some things out for you. Completing a square. So, wow. Okay, ready? It has to look like this. ax, squared, plus bx equals c. So we've got to get that number on the right-hand side. So let's do that first. We're going to add 10 to both sides. Done. Second thing, a has to be 1. If it's not 1, you got to divide everything by whatever's attached to it. So here my a is 5, so that's no good. That's a no good. We're going to divide u by 5. We're going to divide u by 5 and u by 5. Okay, so what does that do? Makes life nice. This is now just m squared. This guy is 2m, and this one is 3. Okay, cool. Next step. Let's make a perfect square. So I know we like to write it like this. M squared minus 2m plus something equals 3 plus something. That something is this. B over 2 squared. We're going to add that to both sides. Okay, so b over 2 squared. b is negative 2. So negative 2 over 2 squared. That's just 1 squared. Sorry, negative 1 squared, which is 1. So we're going to put 1's there, and we're done with that step. Now, if you notice something really cool, this guy, this is why it's called completing a square, boys and girls. This guy right here, if you were to factor this, would look like this. M minus 1, m minus 1. But who's going to write this? We're completing a square. This is what we were asked to do. So instead of writing two binomials, the magic that you just did by adding b over 2 squared to both sides and all that stuff was that it allowed you to do this. You write this squared and set it equal to 4. That's completing a square. It's really nothing that difficult. It's just a procedure, it's a recipe, and if you follow the steps, you'll end up creating this beautiful perfect square trinomial that if you factored using an AM method would give you two identical binomials. So we can just write them once, but put a squared on it. Now, why we do that is as follows. Because you know how to solve for something squared equals a number. You take the square root of both sides. Make a plus and a minus over here. And when you take the square root of something squared, the squared goes away. solving, because it did say solve after all, solving for m is as follows. M equals 1 plus or minus 2. And if you want to be all fancy about it, you can actually do that math. You can say m equals 1 plus 2, which is 3, and 1 minus 2, which is negative 1. Those are your answers. You just completed the square. Awesome. Okay, so determining even and odd or neither for any function. That just means the following. So for all of your x's, you're going to plug in negative x for x. Evaluate it, see what happens. And here's 3 possible outcomes. 1, nothing changes. 2, everything changes. And finally, 3, some, but not all, change. So what happens is if nothing changes, you're an even function. If everything changes, you're odd. And as you can imagine, if only a few things change, but not everything, or not everything stays the same, a few things change, you are neither. So let's take a look at this top one here. Let's plug in negative x for every x I see. So parentheses, of course, negative x cubed plus negative x squared minus negative x minus 1 equals 0. Okay, what is negative x cubed? It's negative x times negative x times negative x. And that, ladies and gentlemen, is negative x cubed. I'm going to add that to negative x squared. That's negative x times negative x, which is positive x squared. And then I'm going to subtract negative x. Okay, well that actually turns into positive x minus 1. So let's take a look. What changed? What stayed the same? Well, I had positive x to the third. Now I have negative x to the third. So that is different. I have a positive x squared and a positive x squared. That's the same. I have a negative x and a positive x. That's different. I have a negative 1 and a negative 1. Okay, that's the same. So look, 2 changed, 2 stayed the same. That seems like something like this. Some of them change, but not all of them. So this is neither. And it's as simple as that. Just plug in negative x for your x's and see what happens. Let's take a look at number 31. Now, 31, negative x cubed minus 3 times negative x equals 0. Negative x cubed is still negative x cubed, and negative 3 times negative x, that would be plus 3x equals 0. Taking a look at what happened, okay, x cubed, the original, ended up like negative x cubed, so that's a change. Negative 3x in the original ended up like positive 3x. Okay, that's a change. So everything changed. Everything. So that's number 2. Everything changed. you are then considered odd, which is a good thing. Whoops. Get out of there. Hello. There you go. Oh, wow. We up to 33 already? Where has the time gone? Okay, 33. Okay, let me just take a drink. Sorry. So 33 is a work problem and a word problem. Work and word. And this is how we agreed in class to view these types of questions. Basically, whatever they're doing, you consider a job. Oops, where are you? Hello. Okay. So you look at it as this: one job over time. And that's the hard part. What we're going to do next is just set up an equation with fractions. Let's see what we have. So it takes 1.5 hours for Tim to mow the lawn. Okay, Tim, so you're going to do one lawn in 1.5 hours. Who else are we talking about? Linda. She's mowing the lawn in 2 hours. Okay, so she can do, this is Tom, right? So Linda, one lawn in 2 hours. I just don't think she likes Tim, so she stays outside longer, that's all. All right, how long will it take John and Linda? Who's John? Wait, didn't we just talk about Tim? Wow. John's the neighbor. Okay, John. All right, let's just consider this one to be Tim. Sorry. I don't know where that came from. That's funny. Okay, so how long if they work together? So that would be, let's say, T and L. One lawn, because they're mowing the same lawn, right? But in how many hours? Who knows? So we put an X there. So let's make this equation. The word problem is basically saying if they work together. So if we add their efforts, 1 over 1.5, that was Tom or John, whoever Linda's hanging out with, plus Linda, she's 1 over 2. Somehow, if we add them, they would be equal to 1 over some value. Hopefully their combined efforts, would make it go quicker. So now we have a rational equation, which is just a fancy way to say fractions in an equation. Our idea is get the LCD of all and cross out the denominators. So the lowest common denominator of all would be 3x. Or, in other words, when in doubt, multiply it out. So as a side note, if you're wondering, how did I get 3 from a 1.5 and a 2? When in doubt, multiply it out. Watch what happens. There you go, 3x. So looking at it this way, by the way, might make it easy to figure out what is missing from each of these fractions. So 1.5 is already in this denominator. Sounds like I'm missing 2x. Okay, this one has a 2, so it looks like I'm missing 1.5x. And last but not least, if I already have an x, I'm missing 3. Once you set this up where the denominators will all be the same, the denominators are gone. And your new equation is just whatever's on top. So you have a 2x times 1 plus 1.5x times 1 equals 1 times 3. Combining like terms, solving for x, x equals 6 over 7 hours, which is a little bit less than an hour, 6/7 of an hour. Okay, so 35 Just like the lawn mowing question, right? One person can clean a house in 5 hours. So here's my house, and it's 5 hours. If a second person helps, the job can be done in 2 hours. So that means someone came along and helped. But we don't know how long it takes them to do the job by themselves. But if they do it together, this would be the scenario right here. So we have person 1 on the left, person 2 next door, and the total of their efforts on the right-hand side. So here's a case where we don't want to know how happy everyone is that they're working together and how fast it's going to be. We already know that. We already know how fast they can do it together. Let's figure out how long it takes this person to do it if this person was alone. So LCD of all is going to be, when in doubt, multiply it out, right? So you'd have 5 times x times 2, which is 10x. Okay, this fraction is missing 2x. This fraction is missing 10x. Nope, just 10, sorry, my bad. And this fraction is missing 5x. Once you set that up so that the denominators would all be the same, get rid of them and just solve for the top. So the top would be 2x plus 10 equals 5x. Okay, let's see. Take away 2x. 10 is equal to 3x. Dividing by 3. X equals 10 thirds. Or x equals 3.333333333. So that's how long it would take the second person to clean the house. 3 1/3 hours. Writing the vertex form of an equation, it was going to look like this, right? You're going to have x minus h squared equals 4 times p y minus k. So p is going to be the distance from the vertex to the directrix or the vertex to the focus. So p, you are the distance from V to D or V to F. So something else to remember, if your parabola, if it opens downward, then your P is going to be negative. Something else to remember, the parabola always opens away from the directrix. It's scared of the directrix. So with all that information, oh, and one more thing, sorry, your vertex in this scenario is going to be HK. All right, so let's see what they gave us. Focus, 6, -2. 6, -2, there you are. There's my F. Now a focus, more notes for you, sorry, but this is good stuff. Focus, always inside. Like a salad bowl, it's always inside parabola. Okay, so I know my parabola either is going to go like this, because it has to sort of like surround the focus, right? Or conversely, maybe my parabola looks like this. I don't know. Kind of depends. Where's my directrix? That would help, right? Or if I knew if this was a positive or a negative P, that would help too. So there's a lot of different ways to figure it out, but you at least have to know that the parabola does surround the focus. Okay, the directrix they gave us, they said it was y equals 0, so that's going to be this sucker right here. There's my directrix. Well, that's my answer. I know it opens down because we said the parabola always opens away from the directrix. Let's go. It's a horrible drawing, sorry, but you get the idea. Looks like Darth Vader's helmet. Now, P is the distance from the vertex to the focus or the vertex to the directrix. The vertex is right at the tippy top. That's our V. And it's always going to be halfway from the focus to the directrix. So this is a tight graph, but you can imagine if you went from 0 to 2, halfway would be 1. So your P is going to be -1 because it's a downward facing parabola, or because the directrix is on top of the focus and it's on top of the vertex. So let's fill in what we know. This vertex is going to be located at 4, -1. So our final form of our vertex equation would be this. X minus 4, that's going to be equal to 4 times -1, that's my P, times y minus k, which is now going to turn into y plus 1. Notice that the vertex form has the opposite signs of the actual vertex. So you'll always have the opposite. So if your vertex is 4, -1, in your equation it's going to be -4 and +1. The last thing we should do, just to be nice, is simplify that a little bit, just so we can write it nicely. So it would look like this. X minus 4 squared equals -4 parentheses y plus 1. And that's the vertex form. Nice. Domain and range questions. Okay, so domain is the x-axis and range is the y-axis. So along this axis here, where does the function live? Being that we have these two arrows heading to the left and to the right, tells me that the domain is going to be all real numbers. Or you can do this, -infinity to +infinity. Always using soft brackets when it comes to infinity. The range is the y-axis. So you look at your y-axis and you ask yourself, all these points on my graph, what y values could they possibly have? Again, looking at the arrows that are pointing northbound, I know that it's going to go to infinity. But now the question is, what's the smallest y value? Because there's no arrows pointing southbound. So this graph doesn't go on forever. What's the lowest point? So you look at the lowest point on your graph, which seems to be here, and that point is 0, -4. So there it is. The smallest y value you'll ever have on this graph is -4. But I'm going to use a hard bracket because it actually hits -4. I only use soft brackets because of infinity, and you know that you could never equal infinity. What if you replaced y with -y? What would happen to your graph? Well, if you solve for y, like as if you were going to put it in your graphing calculator, you can't put -y in there. So let's solve this thing for y. And to do that, I would divide both sides by -1. And here's my new equation. Now, this is easy. We all know what it means to have a negative side a negative sign outside the function. That means that you flip vertically over the x-axis. So, looking at this graph here, that's called the parent because they gave it to us as the baseline. So that's our parent function. Now, they're saying which one looks like this, like they've transformed it in the following ways. So whenever you have something inside the parentheses, this is a shift that's going to be left or right in the opposite direction of whatever that sign is that it says. If you had something outside, this would be a shift up or down in the same direction of the sign. Now we don't have that, but I just wanted to show that to you in case. So what would it be for plus 1? Well, that means I'm going to go left because I'm going opposite. I'm going minus 1. So I'm going to go left 1. So let's take this graph here and shoot it to the left 1. Which picture most resembles that? I would have to say this guy, number 4, because it looks like my little vertex, which used to be here, now just moved over to the left 1 without going up like this one did, without going to the right, which is the mistake of going in the same direction, which you shouldn't. And this one went down 1, which is also not true. This is the correct answer. Use your calculator for this, obviously, but the theory behind it is I've got these absolute value functions like that, or now how did I go from this to a picture like this when you know that normally an absolute value is centered on the origin like this? Very nice and symmetrical. How did it end up here? What caused that? So it's pretty easy to see that it got shifted up by 1. And questions like this, I'm sorry, functions like this are shifting left and right. My function did not do that. So I can cross those two out. Now it's a choice between 2 and 4. Which one of these tells me to go up 1? When you're outside the function with a plus or minus some number, you're moving up or down in the same. So if this says minus 1, you're moving down 1. So it's not this one. The answer is 4.